Bismillahirrahmanirrahim. Project given to us of power distribution and utilization was connection and protection of power system, and in our group members include Majid Mushtaq, Usama Mehboob, Yasir Qureshi and Hamad Akram. From connection of power system, we are gonna first talk on connection schemes, and the connection schemes are of various types, including the simple radial, expanded radial, primary selective, secondary selective, primary loop and secondary network. And now we have a brief overlook on each connection scheme. And the first one is simple radial, and in simple radial you can see here in picture that distribution is at utilization level, and a single primary service and distribution transformer supply all the feeders. And the second one comes as expanded radial. In expanded radial connection scheme, you will see here that distribution is at primary level, and for larger loads we use expanded radial system as in our NUST, because each building has its separate transformer. And third one is primary selective. In primary selective, two separate primary feeders at each substation. You may see here that selection is done on primary bus. And from secondary selective, the only difference is that selection is done on the secondary bus scheme, and two or more distribution transformers are each supplied from a separate primary distribution feeder. The next one is loop primary radial. Loop primary radial is very effective in maintaining the reliability of power system, and the failure of the normal source of a primary cable fault can be isolated and service restored by sectionalizing. And the last one is, you can see, the secondary network, which is most effective among all the connection schemes, but disadvantage is that it is more cost effective but reliability worth the cost. And next comes the protection of power system. What's actually protection system is? Protection system is defined as the series of devices whose main purpose is to protect the persons and primary electric equipments from the effect of faults. And requirements of protection system basically include the maintaining the reliability and selectivity, cost, and the various parameters. And the protection system elements next come, these are the auxiliary components used in the substation, and they are used to perform various operations like including the protective relays, circuit breakers, current and voltage transducers, communication channels, etc. And from protection equipments, now we come to the detail individually. And first one is protective relays. Protective relays works on four principles. First of all, an input is given which may be a current, voltage or a frequency. Then the measurements takes place up to a certain level. If the measurement exceeds, then determination of fault is occur, and then the output is given by the relay. Next comes the circuit breaker. Actually, circuit breaker is an equipment that breaks a circuit either manually or automatically under all conditions at no load, full load or short circuit. Here the picture of circuit breaker, and from different types of circuit breaker you can see here: oil circuit breaker, air blast circuit breaker, SF6 circuit breaker, vacuum circuit breaker. The principle of all the circuit breaker is almost the same. In oil circuit breaker, basically three phases are immersed in oil, and the oil is used as a quenching medium, and these are consist of two parts: supporting chamber and circuit breaking chamber. But the disadvantage of oil circuit breaker is that it is inflammable to fire. Air blast circuit breaker, here the principle is same as that of oil, but instead air is used as a quenching medium. But problem may occur if one of the tripping coil fails to open. Next comes the SF6 circuit breaker. SF6 circuit breaker is the most effective among all the circuit breakers, because hexafluoride gas is used as an arc quenching medium, and it is an electronegative gas. It is much effective for high power and high voltage services. Next comes the vacuum circuit breaker. The major difference in vacuum circuit breaker and others is that here vacuum is used as an arc quenching medium, but have the greatest insulating strength. Fuses, although not so fast and accurate, but they help in maintaining the reliability and protection of our power transformer. And lightning arresters, also known as surge arresters, the current from the surge is diverted around the protected insulation in most cases to earth, and they provide the shortest possible path to the lighting towards the earth, so that may protect our transmission lines. Next comes the section analyzers. Section analyzers are very important in maintaining the reliability of the power system because they help to isolate this fault and help in maintaining the reliability of our power system. Next comes the earthing and grounding.
So actually there are two types of grounding. First one is system grounding and other one is equipment grounding. System grounding is further divided into solidly grounding, impedance grounding and isolated neutral. We will talk about each. First of all, system grounding. First type in system grounding is solid grounding. The solidly grounded system is one that has the neutral connected to ground through an intentional impedance. The advantage is that the size and cost of the transformers are reduced by grading insulating toward neutral point N. The second type is impedance grounding. It has further two types. One is resistance grounding and other is reactance grounding. In resistance grounding, the resistance is connected through the ground, and in second type, reactance grounding is done to lower ground fault currents amounts, often to protect generators. The two types of reactance groundings are Peterson coil and neutral electromagnetic coupler with resistors. Now comes to system grounding pictures. So now a very interesting phenomena, equipment grounding. In normal conditions, we see the current from the transformers go to the circuit breaker and then goes to the load. What happens if one of the hot conductor come in contact with our metal box and one of our friend comes and touches the load? Will he get electric shock? Yes, because the utility transformers are grounded. So we need to do something to our equipment to keep our friend from being electrocuted, and this can be done by grounding. Actually, grounding our equipment provides a second path for fault current. The first path, as you can see, is from our friend to the transformer back, whereas the new path is through our metal equipment to earth and then back to the transformer. And as the resistance in grounding case is very low, so all the current, fault current, goes to the metallic box to the earth and then goes to the transformer, and fortunately our friend is safe now. Nowadays a very efficient technique is being used which is called bonding. In bonding connection, bonding provides a third path for fault currents. There are two types of grounding testings. One is 3-point test and second one is induced frequency test, but we are not going to talk about both the tests here. Transmission and distribution line protection. First one is protection of the transmission lines. The protection of transmission lines is basically done by the distance relays. So they provide protection to transmission line. They are comparatively simple to apply and they operate at extremely high speed. Now the protection of distribution lines. Actually the distribution lines run at a distance of 10 to 30 miles. Primary distribution lines are delta connected, whereas secondary distribution lines are Y connected. Now lighting protections using long flashover arresters. Here is a big picture of lightning, what an lightning can actually do. So in previously, pole tap arresters were used to protect distribution line from induced voltages flashovers. It was recommended to install an arrestor at every insulator, but it was very costly. Nowadays, the technique being used is LFA, long flashover arresters. These are those devices which capture the high voltage sparks resulting out of the lightning. It can be applied for lighting protection of overhead distribution line against both induced voltages and currents. Now comes to the transformer protection. Here's a transformer. So the general faults occurring in transformers are open circuiting fault, overheating fault, winding short circuiting fault, or faults due to lightning. So first, the remedy actions first we talk about is Buckhold's relay. It is a gas evacuated relay. installed in oil immersed transformers for protection against all kinds of faults. So basically this relay is installed in oil quenching transformers. Now the protection from earth or earth fault protection. An earth fault usually involves a partial breakdown of winding insulation to earth. Under the circumstances, it is profitable to employ an earth fault relay. One method of protection is core balance protection, and basically this method is mostly applied. Now the protection against lightning. The most common methods for protection of transformer against lightning are earthing screen, overhead ground wires, and lightning arresters. So this is what all we have today. Hope you have enjoyed our lecture. Thanks a lot.
Click कर दे.